everyone, and welcome to the Unit 8 family video for 2nd grade math. I'm your host, Stephanie Conlon. Today we're going to focus on Unit 8, which is called Equal Groups. This is part of the students' new learning in quarter 4. And by the end of this video, I'd like to make sure that I've answered 3 questions for you. What does my child learning look like? Or what are they learning in quarter 4? How does it look? And what can I do to help at home? First up, for the equal groups unit of study, we talk about odd and even numbers of students. We'd have them start with some counters, maybe 6 like you see here on the screen, and ask them, do you see equal groups, or can we make equal groups with 6 counters? And students might say, yes, I can make 2 equal groups of 3. It's nice and even. I can use 6 counters to make 2 groups of 3, and there's nothing left over. This means that 6 is an even number. So we would hope that students could explain how they know it's 6 by telling how many equal groups that they are able to make and how many are in those groups. Sometimes, though, we might add another counter to our set and ask how that changed things. Does it still look like 2 equal groups? Well, if we start with 7 dots, no, there aren't an equal number of groups because there's this odd one out, right? There's one that's left over, and that makes 7 different from 6 because it has a leftover. It's an odd number. So we'd want to hear students say things like 7 is odd because if I make 2 equal groups, I still have 1 left over. So that's an odd number. There's more than one way to make equal groups though. And sometimes we can pair our idea of equal groups with skip counting to reinforce these ideas and lay the foundation for multiplication. I can find out how many pairs of dots there are by counting by 2s. 2, 4, 6. And if I stop there, I would say 6 is an even number, but there's still 1 left over, and that makes 7. The second part of Unit 8 for equal groups includes a lot of learning around rectangular arrays. And students are introduced to this idea and learn that arrays contain objects arranged into rows and columns, and that each row has the same number of objects. So there are 5 circles in each row. And sometimes we'll tell them like a row is a cross. How many are across? And for the column, we notice that there are 3 circles in each column. And there's 5 circles in every row, and that doesn't change from one row to the next. Sorry, that's hard to say. And that there are 3 circles in each column up and down, and that number stays the same as well, which is why it kind of looks like a rectangle, but because it's made of lots of objects, we call it an array. Students also learn that they can use their ideas about skip counting again in this unit to find out the total number of objects in either the rows or the arrays or the columns. So we could say 5, 10, 15. So we know there are 15 total in this array. Students also relate this idea to skip counting. So if there's 5 in each row, I can represent the total number of objects in this array by using equal add-ins like the same number, 5 plus 5 plus 5, to find the total. So we're connecting the structure of this array to the equation. So I would ask students, where do you see each of these 5s? And where is 15 in this array? Another way that students could also find the total for this array is to skip count in the columns, right? So skip counting 3, 6, 9, 12, 15, so that we are going to add together 3 plus 3 plus 3 plus 3 plus 3, and that still gets you 15. So either way works to get the same total, and we want students to recognize that there are 2 ways to do this. So for Let's Try It, we would ask students to look at an array like the one that you see here, and ask them to write 2 different equations that represent the same number of squares in this array. In that time, when you ask your child to do that, you might ask them also, how many rows do you see? How many columns do you see? And you might ask them like, how many squares are in each row? How many squares are in each column? And then how does each of the equations that you write match the array? Thank you, families, for joining us for our mathematics family video, and thanks for partnering with us at home. We're confident that with your encouragement and support, our young mathematicians will gain a wealth of knowledge and develop a strong foundation in math this year. And for more elementary math resources, you can visit the CMS website. Thanks, and have a great year.